pH metry. Determine the dissociation constant of weak acid by titration of weak acid by strong base. Our requirements are 0.1 normal NaOH, unknown acetic acid solution and pH meter. Let us see procedure. Switch on the pH meter. Replace the 7 pH buffer with 4 pH buffer. And calibrate the pH meter at 4 pH. Wash the pH electrode with distilled water. Insert it in 7 pH buffer. And calibrate the pH meter at 7 pH. Evacuate the pH electrode. And wash it with distilled water. Now insert pH electrode in 4 pH buffer. And calibrate the pH meter at 4 pH. Now pipette out 25 ml unknown acetic acid solution. And transfer it into 50 ml SMF. Dilute it with distilled water up to mark. Shake it well. Pipette out 50 ml from it and transfer in 100 ml beaker. Evacuate pH electrode from 4 pH buffer. Wash it with distilled water. And insert it in the beaker containing acetic acid sample. The reading is 2.84 pH at 0 burette reading. Now fill 0.1 normal NaOH in microburette. Remove air bubble from burette tip. Again fill 0.1 normal NaOH in microburette. Adjusting at 0 mark. Now add 1 ml titrant in titrant. Stir it with glass rod. The reading is 3.55 for 1 ml burette reading. Now see the observation table 1. We can see the jump between 5 ml and 6 ml, that is from 0.40 to 3.89. So we have to expand the scale between 5 ml and 6 ml as shown in observation table 2 and repeat the practical for observation table 2. In observation table 2, we can see the jump at 5.8 ml, that is 2.50. Switch off the pH meter. Evacuate the pH electrode and wash it with distilled water. And insert it in 7 pH buffer. Now from observation table 2, plot the graph 1 and graph 2. The graph 1 is volume of NaOH added versus delta H upon delta V, from which we can get equivalence point V0, that is 5.8 ml. And the graph 2 is volume of NaOH added versus pH, and putting the value of half equivalence point, that is 2.9, we can get pH, that is 4.05. Finally, do the calculation of acid dissociation constant from pH as shown.